Hello, third graders. We are still talking about astronomy, our solar system, and beyond. Today's lesson 5, we're going to talk about gravity. What is gravity? Some vocabulary you'll hear throughout the read aloud. Attraction is a noun. It's something between two objects that draws them together. A black hole is an object or area in space that has such a strong gravity that not even light beams can escape its gravitational pull. That's pretty cool. Force is a pull or a push on an object or system. Gravitational pull is the force that draws all objects in the universe towards each other. Gravity is the force or pull created by the mass of objects that attracts them to one another. Matter is the substances all objects on Earth are made of, all substances that take up space. Tides, the periodic or regular rise and fall of the surface of large bodies of water on Earth that are caused by the interaction of the moon's gravity with Earth. Today you'll be learning about important forces. What do you think a force is? It's not the Force, right? Like Star Wars. It might be similar. A force is a pull or push or pull on an object. Most forces are invisible, but we can often see the result the force has on other objects. So you're pushing a door, you're using force, right? Or if you're pulling a door, you're using force, and you can see the results when the door opens or when it closes. All right. So if I throw an object in the air, what happens? It falls to the ground. The reason an object thrown up into the air comes back down to the ground is the same reason why Earth and other planets stay in orbit around the sun. It is the same reason why all of the gas and dust and stars that exist in galaxies don't just disappear farther into space. It's called gravity. Okay, so if I throw something else in the air that is lighter, the force of friction acts to slow the motion of the object. Friction is a force that resists or tries to stop motion. The force of friction acts to slow the motion of the object. The last time we met, we talked about our amazing Milky Way galaxy. I still have the incredible image of it in my head, a whirling spiral of dust and gas in the light of billions of stars. It is gigantic and it is beautiful. Can you believe we live in it? Let's review what we have learned and seen so far. We live on planet Earth, which is part of a neighborhood called the solar system. And the solar system has 8 planets that orbit the sun. And you remember how scientists classify the sun, right? The sun and the solar system are in a galaxy called the Milky Way. And a galaxy is basically a vast cluster of celestial bodies in space that contains billions or hundreds of billions of stars, along with gas and dust. And there are billions of galaxies besides the Milky Way in the universe, each of which has billions of stars in it. What exactly holds all of this stuff together in this huge universe? Why don't all these stars and planets just go flying off in any direction all over the universe? Why do they stick together in groups and clusters like solar systems and galaxies? These are excellent questions, and the answer is gravity. Gravity is an invisible force of attraction between objects. It's the force that holds galaxies and solar systems together. It's the force that keeps us firmly planted on planet Earth instead of flying off into space. It's the force that keeps Earth orbiting around the sun and keeps the moon orbiting around Earth. Doesn't gravity sound pretty powerful? It is, and it affects you and me all the time. You can't see gravity or touch it, but gravity is present between everything in the universe that has mass. Because of gravity, every single bit of matter in the universe pulls on every other bit of matter in the universe. Gravity depends greatly on mass. So, what exactly is mass? Mass is just the amount of matter in an object. You and I are small compared to, say, a planet or a star. We're made of less stuff, so our mass is much, much smaller. Mass is important when you are trying to understand gravity because the larger the mass, the larger the gravitational pull. So, objects with really large masses, like stars and planets, have a really big gravitational pull on other objects. And objects with really small masses, like you or me, have really small gravitational pulls on other objects. So small we don't even notice the pull at all. The more mass an object has, the more gravity or pull it is capable of. Because Earth has so much mass compared to all of the things that are on the surface of the Earth, its surface gravity keeps the things on Earth from flying off into space. You, your house, your bed, a ball you throw up into the air, all of these things stay on Earth due to gravity. Even the Earth's atmosphere and the oxygen we breathe are held close to Earth by its gravitational pull. Can you point to the thin layer of Earth's atmosphere in this image? Do you see like the haze around the outline of the Earth? Less massive celestial bodies like our moon and Mercury don't have enough gravitational pull to keep gases from escaping into space. That is why they don't have an atmosphere. Gravity also causes you to have weight when you stand on a scale. Earth's gravity pulls down on you. The more mass you have, the harder the pull, and the higher the numbers on the scale. Think about an astronaut who is standing on the moon. The astronaut stays on the surface of the moon because of the moon's gravity. If the astronaut stood on a scale on the moon, the astronaut's weight would be 6 times less than the weight of the same astronaut on a scale on Earth. So a person who weighs 60 pounds on Earth would weigh only 10 pounds on the moon, about the weight of a bag of flour. Because the moon has less mass than Earth and its force of gravity is not as strong. But the astronaut does not get pulled off the moon and back through space to Earth. Earth still has a larger mass than the moon, and it still has a larger gravitational pull than the moon. But because the astronaut is far away from Earth and very close to the moon, the gravitational pull of the moon has the most effect. It keeps the astronaut on the moon. That's the same reason we stay on Earth and the moon stays in orbit around Earth and don't get pulled by the sun's gravity out into space towards the sun. It's another important thing to know about gravity. The distance between two objects affects the gravitational pull between them. Objects that are close to each other pull harder than objects that are farther away. The effect of an object's gravitational pull lessens as you get farther away from it. The sun has a lot more mass than Earth does, but the sun is also a lot farther away. And because we are on the surface of Earth, Earth's gravity has a much bigger effect on us, keeping us firmly on Earth, one of the many benefits of gravity. The sun contains 99% of all the mass in our solar system. Because the sun has more mass by far than anything else in the solar system, it also has more gravity than anything else in the solar system. The sun's gravity, or force of attraction, is so strong that it constantly pulls the planets toward it. You may be wondering why the planets don't crash into the sun if the sun is pulling on them. Don't worry, that never happens because the planets are also moving really fast in their own orbits around the sun. The combination of the planet's own speed and the sun's gravitational pull toward it is what keeps the planets constantly circling in orbit around the sun. It's a perfect balance. The planets continue in their predictable movement around the sun. Sometimes gravity is so powerful that a black hole is formed, an object or area with an extremely strong gravitational pull. There are many black holes in space, and a black hole's gravity is so strong that once something gets close enough, nothing can escape its gravitational pull, not even light. Astronomers find black holes in space by noticing the movement of objects around them. You can't see gravity, but you can observe the way the force of gravity affects objects. Scientists are still learning about black holes, like many other things in outer space. On a clear night, we can often see the moon moving across our night sky. Have you ever been curious about why Earth has a moon? Many scientists think that about 4.5 billion years ago, there was a massive collision between Earth and a very large asteroid. The information they have gathered shows that the moon may have formed from the leftover debris from this amazing impact. Earth's gravity was able to hold the moon in its orbit. There's a strong gravitational pull between Earth and the moon. The moon's gravity pulls on all the things on Earth, including people. But the Earth's gravity is strong enough to keep us on Earth. Whew! That's a good thing. The moon's gravity also pulls on Earth's oceans, but the Earth's gravity pulls back, and it's a good thing it's stronger. The moon's gravity is just strong enough that it can move the water on Earth enough to cause tides in the oceans. Tides cause the regular rise and fall of the ocean's waters. People can see the effect of tides if they are at the seashore. High tides cause the waves to come high up on the beach, and when low tides occur, the waves don't come up as far. Low tide is a good time to walk the beach and look for shells and creatures that live in the sand. So yes, the powerful effects of gravity can explain a lot of interesting things in the universe. It's what holds our moon in orbit around Earth. It's what causes ocean tides on Earth day after day. Gravity is why we stay on Earth and why objects we throw into the air come back down. Gravity even helps create new stars and planets by helping pull together the gases and dust that form them. We can't see gravity, but we can see its effects all around us, on Earth, in our solar system, and throughout our galaxy. It's a pretty picture, illustration. Alright, so let's remember, what is a main idea? Remember, it's a topic, 1 or 2 words about what the whole text is about is your topic. Your main idea is the most important point or thought about the topic. So what is this passage mostly about? What is the main idea? Remember, it has to be supported by different examples and details from the text. What was our main idea? Right? Our topic was gravity, right? Our main idea you could say something like gravity is important, or gravity is what keeps our solar system together. What did we learn about? How did this image contribute to our read aloud, to our text? What did this image show you? What do those arrows mean? The main idea illustrated in this diagram is objects with larger masses exert more gravity on other objects than objects with smaller masses do. What features of the diagram help demonstrate the main idea? Well, if you look at the arrow, the thickness of the arrow shows how strong the gravity is. If the objects are similar in how packed together the atoms are, then the larger objects have more mass than the smaller ones. How are our everyday lives affected by the gravitational pull of Earth? How would our lives change with less gravity? Good question. All right. Our word for today is gravity. In the read aloud you heard, gravity is an invisible force of attraction between objects. And the more mass an object has, the more gravity or pull it is capable of. Say the word gravity. Gravity is a force created by the mass of an object that attracts another object to it. The amount of gravity created by an object depends on how much mass it has. A celestial body, like Earth, has a lot of mass, so it exerts more gravity on other objects than a smaller body like the moon would. What do you think it would be like to live on a planet that has less gravity than Earth? Would it be harder or easier to move around or jump? All right, good job, third graders. Hope you enjoyed learning a little bit about gravity.